In Swift, classes are defined almost the same way as structs. I simply use the class keyword instead of struct. Classes can inherit properties and methods from another class. Place the superclass's name after a colon. In this example, my subclass inherited the property type from my superclass and added image file name. Unlike coding in Objective-C, where almost every little class is a subclass of NSObject, in Swift you'll be making a lot more classes which are not actually subclasses of anything. That's largely thanks to Swift including lots of functionality from the NSObject class right in the Swift language. Inheritance means the subclass can do everything and go everywhere the superclass went. Here's a function which accepts instances of my superclass. I can also pass in instances of a subclass of my superclass. However, Swift also supports picking a function based on the type of the arguments. Here, the declared type of the instance determines which function will be called. Since the declared type is the superclass, it calls the function which takes the superclass as an argument, instead of calling the function with the subclass. But our original call where the compiler knows the argument is a subclass calls the version of the function which takes the subclass. So Swift supports both substituting subclasses in function arguments and picking functions based on the type. My personal recommendation is that you don't write functions with identical names that choose which function to call based on subclasses. Instead, let these methods call on unrelated types. A subclass can override its superclass's methods and properties. To do that, it requires the override keyword. You might be wondering, can't the compiler figure that out? Yes, it can. That keyword's there for you. Here, my subclass overrides its super's definition of do something. So even if an instance is known to the type system only to be the superclass, the runtime system calls the method on the class as instantiated. That's called dynamic dispatch, which means the correct method is looked up at runtime. It's slower than static dispatch, the kind used for functions which can't be overridden. Subclasses can access their superclass's implementation of a property or function using the super keyword. In this example, the subclass calls the superclass's function, so they're both called. Note that we haven't written any init methods, and we're not going to talk about them until the next video. For now, just know that classes only get default empty initializers when all stored properties have an initial value supplied. It may not look like I supplied any initial values here, but optionals are special, since they have an implicit default value of nil. Unlike a struct, a class is a reference type. We've compared a few value types with a double equals operator. The doubles equal operator is for testing equivalence. In other words, it tests whether one instance can be substituted for another because their values are the same. Equivalence usually doesn't mean anything for reference types. What matters is their identity. In C-based languages, you could check whether two objects had the same identity by testing the equivalence of their pointers. Since Swift hides the actual pointer values from you, we need another way to test. Use the triple equal operator to compare the identities of two objects. In this example, even though A and B have no stored properties, they cannot be identical since they were initialized separately. However, when we set B equal to A, testing for identity succeeds. Built-in identity checking makes classes the right thing to use for nodes and edges in a graph. Remember from last week that changing the value of a property of a struct made an implicit copy of the struct, leaving the properties unchanged in the previous scope. This meant changes to properties couldn't inadvertently affect other portions of the program. However, sometimes we want those changes to affect other portions of the program. Here, we've changed the type property on some instance, even though it is declared as let. The function was able to affect outside scope by changing properties of the class. Unlike structs, an instance of a class is not implicitly copied. In fact, class instances usually aren't copied. Another consequence is a class's methods are never marked mutating. It's just assumed that calling a method on a class could change its properties in some way. So when reading Swift code, pay attention to whether the types are used as value types, like structs, or reference types, like classes. When writing, think carefully about which one best suits your needs. Today we covered the fundamental aspects of a class as a reference type: inheritance, substitutability, overriding, identity, and mutability. A special operator just for checking reference identity. Now that's swift.